All right, we're back. We're still on page 5 of notes 13. We're finding antiderivatives. I was just pummeled by this one, where if you go wrong, when you make the wrong u substitution, things go wrong. I tried to make u equal the thing inside the radical because it seemed like a good choice. I got a little distracted by like trig identities and all. I don't know, a lot of excuses. It just wasn't working. I couldn't get my way out of there. So you know what I did? I went to the calculator. I had the calculator do it. I saw the answer and I was like, oh, now I know how to do it. So is that cheating? Definitely. But you know, you got to use all your resources. We're all learning all the time. All right, this one though, I think we can do, right? So there should, by the chain rule, be a -7. So I need a -1/7, then a 1/5. So -1/35, and then 5 minus 7x to the 5th plus c. That's the answer that we're going to get. If we do the substitution, we say u is 5 minus 7x. Then d, let's say -1/7 du is dx. And so it becomes -1/7 u to the 4th du. So like the more you do them, the more you get a sense of like the things that I'm saying when I'm like, well, we need a 1/5 and we need a 1/7 and blah, blah, blah. I think the more you do those, the easier it is to follow along. So like this might be the type of video where you have to watch more than once, or these are the sorts of, work them out with other people. I think talking through these problems with others is like a really good idea. So here, this like this should be u, so there should be a 1/5, which means there should be a 5, and then the derivative of sine is cosine. So we're going to get this. So let's do that. U is equal to x over 5, so 5 du is equal to dx. So we're doing the integral of 5 cosine of u du. And then that's going to take us up here. So you can do that. I believe in you. You should believe in you. I find at the beginning of this, usually I believe in people because I've like hundreds of students. I've never had one who couldn't do this. But at the outset, it feels very intimidating, I think, to the individual student. So people argue with me. They're like, oh, I can never do it. I'm like, yes, you can. You definitely can. So this 6x should have put a 6 here. So I'm going to put a 1/6. The derivative of cosine is negative sine, so we need a negative. And cosine of 6x and plus c. So this is what we're going to get. I remember plus c after all that rampaging. Yeah, I did. Okay. So let's do the substitution. So u is 6x. So this is like a weird order to go in, where I'm like solving them and then going back. But I want you to get to the point where you can solve them too. So I'm trying to show you, like, it's like when you're learning to solve algebra equations, like it drives me insane when like you have like x plus 2 equals 5, and then somebody's like -2 minus 2. That confuses me. I hate it. And so I find like this is sort of a similar thing where like sometimes the more that you show, the harder it gets. And I believe you can do these. So this, if we make our substitution, will be 1/6 sine of u du, which is going to take us up to there. All right, let's carry on. All right, what do we got here? Well, this is, first of all, this is like a famous type that in Calc 2, for whatever reason, this type of integral comes up a lot. In like weird ways, because like why would it ever come up? But it does. I'm going to say that we want to make u equal natural log of x. And the reason I want to say that is that the derivative of natural log of x is 1/x, which is like kind of already there. And so du is going to be 1/x dx. And so I will do the highlighting thing on this one. This is this. And then du dx, obviously. Well, dx rather. And then this 1/x is actually there. It's this. So we can turn this whole thing into du, which is 1/x dx, over u, right? So it's weird because this is the natural log of the absolute value of u. So I basically know how to do this one from experience. Like you do this problem a lot. I don't know why, but you do. But then u is equal to natural log of x. So we get natural log of the absolute value. Maybe I'll alternate my colors or something. The absolute value of the natural log of x. So that natural log does not have absolute values around the x because the original u does not. close the absolute value, close the parenthesis for natural log, plus c. Super weird. Experience, practice, experience, you notice it and you're just like, yep, it's that one again. You'll also see like weirder problems where it's like 1 over x, natural log of x, natural log of natural log of x. I think you can like keep going like forever-ish on that, like as long as you keep like having the things. I obviously don't recommend that. All right, what are we doing here? So I see cosecant squared of sine and then times cosine. Well, the derivative of sine is cosine. So like this, it feels like if I make this u, this is just going to be du, and then it's cosecant squared of u du. Seems doable because cosecant squared is almost the derivative of cotan. So let's say u is sine of x, du is cosine of x, dx. All good, right? We got cosine, cosine, we got dx, dx, and then we have a u. So like when you make your u substitution, it doesn't mean your function's not gonna still look a little weird. Like, I mean, cosecant, ooh, gosh. Cosecant squared doesn't look necessarily simple, but we know what we're doing. So it does look simpler because we memorized. This is negative cotan of u plus c, and then u is sine. So we're gonna get negative cotan of sine of x plus c. Feels like maybe that would simplify, but it doesn't. It's like cotangent of sine. Like, what are you gonna do? So, all right, that's the whole page. The worst part of the page for me certainly was E, which I got stumped on, which happens from time to time. But anyway, we're done. So again, maybe watch them again, think them through. Try to do some in your head. Like it feels impossible at first, but it just keeps getting easier and easier, and eventually you're like kind of a master of these things, and that's really your goal. So I'll be back in the next video to do some more, and I will see you there.